This is a recording showing the internals of the Neo Funbit project. You can see the green 3D printed case that holds the electronics, and there's a cover with the display on it here, with a connector that connects here. This is a Adafruit Bluefruit LEMO microcontroller, and we're connected to the ground. Looks like USB right here, the red one, and pin, I think 6 here. And this is the Bluetooth module that actually communicates with the mobile phone, Android or iOS. And here is a connector for a JST connector for the battery, which we have in here, which you can read the milliamps on, 3.7 volts, 6500 milliamps. And it's a reasonably thick battery that fits just in the case. And then the wiring has been reversed because the input on the JST, and this is very important, the positive and negative are reversed on this board from this battery, which is, I believe, like a cell phone battery or something like that. So so it's reversed, so you have to reverse that, okay, here. And while you're doing that, you should put a switch in there where I've soldered the points to connect on the switch. That is flipped right here, and I've just glued that switch down with some super glue, so we'll see how good that sticks. The rest of these parts are adhered with double-sided tape. So I have tape that's double-sided, sticky on one side and the other, and you peel off, and that's holding down the battery. There's just enough room for that in the case, and then the board, which is holding down. And the hole down here is a little bigger than usual, so I could reach in and hit this reset button if I really have to, if I seal up the case. So the case is a little large right now, but it's going to be more precision in the future. Okay, and then the whole unit itself, you can see the parts on through it, but this is fluorescent green, just experimenting with different materials, and the top material here is nylon. Okay, so I 3D printed some nylon, which feels better than and softer than the harder plastic below, which kind of holds everything framed in place. This is metal, flexible display, and it's been taped in here with Scotch tape. There's just enough room to fold this over and hold this in here, and it's important to tape the edges here so that the display doesn't drop down, and then the battery kind of holds it up in the front, and then it's all pressed closely against, because if it separates from that too much, it tends to blur a lot. Okay, and so we'll film another video in a moment showing the display. And we've tested the battery on it, and it seems to run continuously, at least for a day, a full 24 hours, given that it's such a large battery, and that's why I chose it. And then to charge the battery, you need to plug it into a USB. Okay, sorry, you're seeing my legs there. You need to plug it into a USB, and you plug it in down here. Okay, and then it will charge up if it's on a 5 volt charge, and a yellow light, yellow orangish light will come on, showing that it's charging. It's only 100 milliamps charge, so it's going to take quite a while to charge this battery up, but it also runs while it's charging. So you know, if you want to mount this on a wall or something, it'll work or if it's a wearable, you can wear it on a backpack or even around your neck with a lanyard. So that's basically it. Let me see if I forgot anything. These printed cases take quite a while to print on a 3D printer. Some of these take up to 8 hours each or more. So we're looking at 16 hours printing at minimum. And then assembly is pretty quick. We're looking at a number of different solder points, 3 on the microcontroller, 2 to connect up the wiring, and 2 on the switch. So 4 and 3, at least 7 solder points, and then a snap-on connector. This comes soldered from China, and I've clipped off these other connection points. There were wires here that are not used, so there's no reason to have them hanging out loose. And so there's a lot of room in the case, and that's good because it gives the battery air. And then the metal here is coated, and then this battery is coated. So unless somebody spikes through the case, damaging the battery, the wearer should be protected if it's a wearable, because there's a pad holding it down on this side and that side. So in terms of safety, and because of this larger hole, there is a positive side to that. There's a lot of ventilation that can occur inside the case, especially if there's heating or this thing is left in the sun, although I don't recommend it because we haven't really tested that. So I think that's about it. This is a prototype, and it's being called a Neo Funbit. Okay, and I'm working on the software now for programming it and animating the display. It's a 16 by 16 display, giving you 256 very bright multicolored pixels that can occur here. All right.